Chapter 9, Weathering and Soils. The dirt on weathering: physical weathering, chemical weathering, biological weathering and decay, weathering rates, soils and introduction, soils erosion and conservation. We'll begin with dirt on weathering. For water continually dropping will wear hard rocks hollow. Were these volcanic rocks originally formed with large holes? And how did they develop the appearance of Swiss cheese? Weathering is the physical, chemical, and biological breakdown of rocks and minerals. We will be looking at 5 different World Heritage sites. Here's Mesa Verde, the Parthenon, Machu Picchu, Kilwa Kisiwani, Tanzania. Soil forms slowly by weathering and is often eroded faster than it's replaced. Loss of soil is a threat to agriculture, influenced by activity and natural factors. A thin soil layer over bedrock, the weight of the material up here, puts these buried rocks under a great deal of pressure. This part eroded away. This part acts kind of like a spring and expands. That's what has happened in this area. Pressure released fractures at Half Dome in Yosemite National Park. Now these granite outcrops are in the Sierra Nevadas. Which one actually contains pressure release cracks? They both do. Physical weathering: the disintegration of rocks and minerals into smaller pieces. Wedging: the water enters cracks in surface materials like rocks and roads. The temperature drop causes the water to freeze and expand, and it forces the cracks to expand. The process repeats when ice melts. Water finds new cracks, freezes again, and expands the cracks. An example would be potholes. Now, water is about the only material that needs more space when it freezes. There's your typical pothole. Wedging can be caused by other substances. The growth of salt crystals in small rock openings is shown here. There's honeycomb weathering, a result of salt crystal growth on the surface of a rock, expanding the size of the hollows. Physical weathering actually breaks rocks into smaller pieces, increasing the surface area over which weathering can occur. The decomposition of rock due to the chemical breakdown of minerals is called chemical weathering. Dissolution is when minerals in a rock are dissolved by water. An example would be the acid rain removing the details of a statue, like what happens in Rome. Hydrolysis: hydrogen ions in water replace other ions in silicate minerals. An example: feldspar reacts with water and H ions to form clay, which is used in manufacturing glossy magazine paper. Oxidation: oxygen reacts with iron and other metals to form new mineral compounds. For example, the rust on your car. Take a look at these 2 stones. Chemical weathering has actually removed the details so that it can't be read on this one. But this one, the details are still there. They're different materials. This one's marble, this one's slate. They're both about the same age, yet one has weathered better than the other. A statue that has lost its detail. A sugar cube disappearing in a cup of coffee is an example of dissolution. Carbon dioxide is a small portion of the air we breathe, but when combined with rainwater, it creates a weak acid called carbonic acid, which can dissolve limestone and marble. Limestone is very common on Earth's surface. The dissolution of limestone creates karst landforms. All rocks contain some cracks. Water-carrying dissolved limestone is transported through caves and may precipitate the limestone out of solution as stalactites and stalagmites. Sinkholes are large depressions on the surface where limestone bedrock has been dissolved, resulting in the collapse on the overlying surface. This has become a problem in the United States and other places around the world. When hydrogen ions replace other ions in silicates, hydrolysis, the silicates become weaker and more likely to break down. Well, where do the hydrogen ions come from? Hydrolysis and dissolution can occur together to chemically weather a rock more quickly. The more hydrogen ions there are, the more rapid the chemical weathering. Here are some values for everyday materials. Some of these things are more acidic on this side, they're neutral, and more alkaline on this side. All rainwater is mildly acidic. Pollutants such as sulfur dioxide, nitrogen oxide significantly decrease the pH of rainwater, which increases the acidity. The pH is logarithmic. Each increment represents a 10-time increase or decrease in the hydrogen concentration per volume of solution. Acid mine drainage is evident in this photograph. Water has reacted with the iron in the water and the sulfur that has been released, and a distinctive orangish color is evident right here. The biological weathering and decay. Believe it or not, critters, plants and animals, can remove and or break down rocks and minerals. This can be done macroscopically by the organisms we can actually see, the big ones, macro meaning large. This includes the actions of plant roots, animal burrows, termites, and other boring organisms. Microscopic, very tiny, the organisms we cannot see with the naked eye because they're too small. They primarily cause the decomposition of material that converts solid material to gases with or without water. It mostly works on organic material like dead plant or animal matter. The tree roots force apart the rock along the original fracture, and you can see that this tree root has cracked this rock right in half. Chitons and sea urchins are responsible for excavating holes in the bedrock under shallow marine conditions. Here you can see the limestone has been undercut due to biological weathering and the activities of small organisms. What controls how quickly a rock weathers? The composition of the rock, the properties, the climate. These rocks have low porosity, and weathering is restricted just to the outside. That's why they have, it looks like a peel around them. Composition as a variable. Weathering is faster in rocks composed of weaker material or material that's easily converted to weaker material like feldspar. Weathering is faster in rocks made up of minerals that dissolve in water, like salt or gypsum. Weathering is slower in rocks made up of resistant materials, like quartz. The rock property is a variable. Weathering is faster in rocks that allow air and water to come in. It's more porous or fractured. Fractures are natural weathering surfaces. Igneous and metamorphic rocks generally have low porosity. Do you think they are particularly susceptible to weathering? Climate as a variable. Climate is a region's average annual temperature, precipitation, and vegetation. Climate is not weather. Weather means a specific condition at a specific time and place. For instance, right now, as I look out my window, it's sunny and warm outside. This is not the climate here. It's just the weather. Climate would be what's it like over a long period of time. Chemical weathering is faster in warmer climates. The more water, like rain and humidity, the more dissolution and hydrolysis reactions can occur. The more shade provided by vegetation can impede evaporation and allow more water to find its way into cracks, thereby increasing the rates of weathering. Carbon dioxide released from plants can combine with water to make carbonic acid. Higher elevations may have more freeze-thaw cycles, and that increases the rate of physical weathering. Extremely cold regions don't have much thawing, therefore, not much wedging occurs. Soils from different areas of the United States are shown in these photographs. What do you notice about them? Why do you think they look so different? Soil is a stratified mixture of regolith that includes enough organic material, water, and air to support plant life. Organic material is supplied by decaying plants and animals. Organics get mixed with the soil by burrowing animals, worms, and insects. The water moves through the soil and it leaches. In other words, it dissolves iron. Water can transport fine clay particles to the lower levels. It kind of sifts the finer pieces. Soil profile, a series of distinct soil horizons. The horizontal layers are created by organic activity, leaching and precipitation, and transport of clays. There are a number of factors that affect the type of soil that is in a specific location. Characteristic soil profiles. O, organic debris, dead leaves, Plant and animal remains make up 30% of this layer. It's usually on the top. Why is that? A is the topsoil. The dark organics mixed with mineral grains by organic activity. Lacks in fine particles and the soluble ions. E, subsurface layers that have most of their minerals and can be embedded in a horizon or replace a horizon. B, ions leached from A are precipitated here. This includes the clay particles that were carried down from A. There's little organic material present. The red color is due to oxidation in the rainy areas or accumulation of calcium carbonate in the arid areas. This forms a white layer. C is the lowest layer of soil. This consists of soil parent material, either weathered bedrock, regolith, or unconsolidated sediments. Soil formation is controlled by the rock in the source area, the temperature and the amount of rain in a region, or the climate factors, and the biological activity occurring in an area. Here's a graphic showing the different soils and their location around the globe. Soil fertility. Thick soil is not necessarily fertile soil. Fertility changes over time depending on leaching and replacement of nutrients by weathering. Heavy rainfall can carry away the soil nutrient. For example, rainforests have dense vegetation, but the extreme rainfall carries the nutrients away, leaving only the top few centimeters of soil fertile. Not only that, but in the rainforest, that's one of the most biodiverse areas of the world, there's a lot of competition going on. Whatever nutrients are in the soil is used by the vegetation that is there. The effect of climate on soil profiles. On the left side, we have an arid area, and on the right side, we have a temperate area. Under what type of climate did this soil form? This is in Brazil. Soils form very slowly, and it's often depleted faster than it can form. Soil erosion rates are affected by the climate factors such as water and wind, and land use practices. Think of the Dust Bowl. Erosion of soil by wind and water occurs when soil particles are detached from the soil column and they're transported away. This is controlled by the amount and frequency of rainfall, wind velocity, the character of the soil, the vegetation cover, and the slope of the land surface. This is an impact of a raindrop that is loosening the particles of the soil, and then they can be transported away by the flowing water. On the left, you can see that water has actually made some channels or little valleys in this field. These are known as rills in a plowed field. This is in Iowa. On the right-hand side, the wind is blowing away the dry particles. And speaking of fields, look at the Dust Bowl. This was a big problem, a big dust storm approaching a town in the Great Plains during the Dust Bowl era. The Dust Bowl. The orange highlighting in the middle marks the areas of the Great Plains states that lost the most soil during the Dust Bowl. Now, this does not mean that it didn't occur farther south or farther north. Each dot on this map represents the erosion of 200,000 tons of soil due to water, which are the blue dots, and wind, the red dots. Humans are now more important as agents in moving soils and sediments than all other natural processes operating on Earth combined. Agriculture can accelerate soil loss. Poor soil management causes widespread soil erosion. The highest erosion rates are in parts of Africa, South America, and Asia, where farming practices are not well regulated and rainfall is abundant. The lowest erosion rates are generally in Europe and North America, where the governments encourage preservation of soils by good agricultural practices. The economic cost of soil erosion in the U.S. alone is estimated to be tens of billions of dollars a year. Farmers have to know a lot about soil and erosion and how to conserve their soil. The photograph at the top is of young soybean plants that are grown in the residue of a previous wheat crop. The wheat crop had been planted to protect the soil from erosion. The second photograph is contour farming of cropland in southwest Iowa. Here you can see terraces in California. This is in a vineyard. The terraces are there to prevent water erosion. This photograph shows a line of trees here that were planted to protect the field from being eroded away by the wind. This is strip cropping. It's alternating bands of corn and oats and alfalfa. It's reducing the erosion in a field in northeast Iowa. U.S. farmland under conservation tillage, which are methods of conservation including covering soils, limiting contour plowing and terracing, and ensuring a steady supply of nutrients. This concludes Chapter 9.